Welcome all to my channel. In this video class, we see about conic sections. Listen to the drawing sheet. Here, the brief details about conic sections are given. A simple right circular cone is considered as shown with the base. This bottom place is called base. Then the center line of the cone is called as axis, and various imaginary lines from the top to bottom is called generators. There are many number of generators, imaginary lines. When this is assumed to be cut by a cutting plane at different angles, that is, the cutting plane may cut parallel to the base or at some angle likewise. In those cases, we can get profile curves like circle, ellipse, parabola and hyperbola. These types of curves are called conic curves. Referring to the drawing, it shows the general terms used. There is also another condition to obtain these types of curves. When the eccentricity E is less than 1, it produces an ellipse. When the eccentricity E equal to 1, it produces a parabola. When it is greater than 1, it is a hyperbola. For this value of E, you may see the relationship shown, that is eccentricity E equal to distance from focus divided by distance from directrix. This I will explain here. This is the relationship between the eccentricity E. Next, the terms given in the figure are very important because in many problems the terms will be given to understand and solve the problems. Now, referring to the figure, the vertical line that has been shown here, that is called directrix. The vertical line is called directrix. One of the important word to remember for the problems, because sometimes in the problem they may give the word directrix. This F is called focus. That is how much distance the focus is from the directrix line. Likewise, they may give. So, they may use the word or symbols in some of the cases instead of giving the name of the curve. So, all these terms must be remembered without fail. So, directrix we have seen. Next, the center, that is the horizontal line. This one. This line as shown is called as major axis. Next one, you see the perpendicular line which is perpendicular to the horizontal line. This line is called minor axis. This is also parallel to the directrix. Now, see the curves. Here, this one name is called hyperbola. First one, you see hyperbola, and also for this hyperbola we already seen E is greater than 1, and also vice versa. You remember, either hyperbola should be when E greater than 1, or when E is greater than 1 it should be a hyperbola. Likewise, we got to see for all. Then next, see the parabola. Second one, this curve is parabola curve. In this case, E is equal to 1. E is equal to 1, then it is parabola. Then next curve, third one, that is ellipse. Here, E equal to less than 1. When E is equal to less than 1, an ellipse as shown here. The name is given ellipse. This will be the ellipse when E is less than 1. This condition should also satisfy, or otherwise when E is less than 1, it is indirectly assumed that it is an elliptical curve. Then F, F dash, which are given, are called as focus points. F, F dash, focus points. It is also important to decide about the curve nature. Now, looking into the term E, once again, to understand distance from focus, we have seen F is the focus. So, distance from focus and divided by distance from directrix. That is, to understand, see one by one. First, you take this point L. That is distance from the focus. You see the distance. Actually, it is to be measured, but approximately, just by appearance, we understand. This is the lesser length when comparable to FL. This FL is called distance from the focus, and this one is called distance from directrix. This L is distance from directrix, same L is distance from focus. You see these two lengths. When you are seeing the relation, distance from focus, this is higher value, distance from directrix is lower value, so automatically it will be greater than 1. Here E is greater than 1, it is a hyperbola. This line point is coming in the hyperbola. Likewise, next you take the point K. Here distance from focus, this is the distance from focus, this is the distance from directrix. Both length are equal almost, but you should calculate and decide in the problem. Exact value should be considered, not approximate. Just for understanding, I am telling this. Since both are equal in the length, then this E value will be 1. When E is equal to 1, it will be a parabola curve. Indirectly, from the values, you should find out whether curve nature is ellipse or parabola or hyperbola. That's why this equation plays a vital role. Then third one, you see ellipse. For ellipse, the point is given at this place. So here the distance from focus, this is the distance. This is the distance from directrix. So this value is lower, this value is higher. So definitely value will be less than 1. So when dividing, E will be less than 1. Then it directly indicates it is an elliptical curve. This is the way in which this equation is used to decide what type of curve has been given. And also the directrix is very important. From the directrix, what is the distance through which the path of the curve is moving on. For example, hyperbola is moving on in this path, parabola is moving on in this path, ellipse is moving on in this path. That is the reason directrix is also important. I think these terms are sufficient at this stage. All these terms you can easily understand when they are used in the successive problems. Okay, with this introduction details to the conical curves, we see the applications in the problems. Thank you all. We see in the next video class. Thank you once again.